Hello students, let us continue with the chapter Atomic Structure. In this video, we'll start with the drawbacks of Rutherford's model, the atomic model. According to his model, electrons revolving around the nucleus have centripetal acceleration, and according to thermodynamics, accelerated charged particles radiate energy in the form of electromagnetic waves, and if they radiate energy, and due to the continuous loss of energy of the electrons, what is going to happen? The electrons ultimately are going to fall to the nucleus. That's what his model explained, but this found that it is not correct. If it happens, then the atomic model won't be possible. Later on, Bohr atomic model was presented by Niels Bohr, and he somewhat rectified the defects of Rutherford model. His postulates are: number one, electrons revolve around the nucleus in definite closed circular paths called orbits. Each orbit is associated with a definite amount of energy, therefore also known as energy level. These orbits or energy levels are numbered as 1, 2, 3, 4 or K, L, M, N, and so on from inside onwards. Bigger the orbit, greater is the energy associated with it. Now, they are also called principal quantum levels, the energy levels, and they are represented by N. Limitations of Bohr's postulates. He could explain spectra of multi-electron system. Then there was no explanation of fine spectrum of atoms, no explanation of Zeeman or Stark effect, this effect of electric and magnetic fields on the spectral atoms. When the magnetic field is applied on an atom, it is usually observed that spectral lines split. It is called Zeeman effect, and in case of electric field, the splitting of spectral lines known as Stark effect. It was not explained by Bohr's model. Now let us know about cathode rays. They originate from cathode. Cathode rays travel in straight line. Cathode rays carry negative charge, and cathode rays are deflected by electric field, and they are also deflected by magnetic field. Right, this was observed by the experiment done by J.J. Thomson, where the discovery of electron took place. You'll see that the properties are more or less very much same as the electrons. The ratio E, that is E by m of these particles, we later found to be electrons, was 1.76 into the power 8 coulombs per gram. Cathode rays consist of electrons. The rays, upon striking glass or certain other metals, cause them to glow. Example, tungsten, etc. Let us know about anode rays. Anode rays also travel in a straight line. They are having material particles. As they have mass in them, they are positively charged. They may get deflected by external magnetic field, and they also affect the photographic plate. We'll move on to the other properties, but they affect, since they are material particles, they show mechanical energy also. Let us move on. Some more properties of anode rays. The E by m ratio of these rays is smaller than that of electrons, and unlike cathode rays, their E by m value is dependent upon the nature of the gas taken in the tube. So this over here. There is a difference between cathode and anode rays over here. It is maximum when gas present in the tube is hydrogen. Okay, so now moving on to the valence electrons. Electrons are distributed in various shells at different distances from nucleus. Electron energy increases as the shell radius increases. Electrons in the outermost shell are called valence electrons. The outermost shell are called valence electrons. Take part in the chemical reactions. Elements in the periodic table are grouped according to the number of valence electrons that we have seen in the periodic table, with the arrangement of elements under various groups and periods. Okay. Next, electronic structure of an atom. The electron in an atom are arranged in the shell around its nucleus. They start to fill up the shells from the inner shells to the outermost. The first shell is the shell that is nearest to the nucleus and can hold just 2 electrons. Second shell can hold 8 electrons. Third can also hold 8 electrons. All of this is called electron error electronic configuration of the atom. So this number of electrons in various shells decided by the formula 2n square, but it is seen generally that the outermost shell and the penultimate shell, that is the shell next to outermost shell, contains 8 electron at the most, can contain 8 electron at the most. Hydrogen and helium atom are exceptions where the doublet rule applies. But in other cases, all the other atoms, octet rule applies, which means that the outermost shell has a maximum of 8 electrons to gain stability. So with this, we come to the end of this module. We'll continue with atomic structure in the next video as well. Thank you.